In this problem, we're going to do a two-sample proportion test to determine whether or not the proportion of maternity patients who intend to breastfeed has increased. So in the file baby, and you should have had access to this file from class, what we have here is in the first column, January BF, what we see is yeses and nos. A survey was done to see whether or not the patients intended to breastfeed. So this January was just yeses and nos, was held before the staff received a program and initiated a program that they were forced to do. So the January, they looked to see if the patients intended to breastfeed. The staff went through a mandatory training session, and then they afterwards looked at other patients, determined whether or not those new patients after the training wanted to breastfeed or intended to breastfeed. So what we want to look at is the very last part here. We want to look at, did the training sessions help, or did they help to increase the proportion of patients who intend to breastfeed? So we want to look at those who said yes before. Then after the training sessions were initiated, we want to look at those who said yes afterwards to see if that proportion increased. So what we need to do, and what I'm going to do, is to first look at the sample proportion for the January survey, and then the sample proportion for yeses for the September. So I'm going to call, this is going to be P1, and this is P1 hat, so this is the sample proportion. And this is going to represent the sample proportion of yeses before the program. And then P2 hat, I will call the sample proportion of yeses after the program. And we want to see whether or not this proportion for P2 hat is increased. So let's look at P1. Let's look at the proportion of patients who said yes. So I'm going to go into data. I'm going to sort my column, and I want to sort January by January, and I'm going to click on descending, because if you actually click on descending, it will start with the yeses and then go to the nos. So if we look at worksheet 4 here, I see that all the yeses, how many yeses do I have? I have 44 yeses. So I have 44 yeses out of a total of 71 patients. So 44 out of 71, and I got that just by looking at the yeses. And when I put that in the calculator, I get approximately 0.6197. And we can round that. So let's round that to approximately, we'll just go to 3 decimal points here. We'll round that to approximately 0.620. Now if we do the same thing, we want to look at the proportion of patients who said yes after a program was initiated. So this is the September. So I'm going to sort, where'd it go? There it is. I'm going to sort September by September, descending. So what I find is the proportion of mothers who plan to breastfeed, there are 49. 49 said yes, just going down. 49 said yes out of 68. So there was 49 that said yes out of 68. And then if I put that in the calculator, we get, I'm going to round this to 3 decimal points, 0.721. So P1 hat was equal to 0.620. P2 hat was equal to 0.720. Now just looking at that sample, it looks like the proportion is higher. But is this second proportion statistically higher? Is it statistically different and larger than the sample proportion from the first sample? In order to do this, we need to conduct a hypothesis test. We need to conduct a hypothesis test. So what I'm going to do is I'm going to, first of all, write my null and alternative hypothesis. So there's my null hypothesis and my alternative hypothesis. We know the null hypothesis is that there's no change. So we're going to just assume that the proportions are equal to each other. Knowing what we talked about in class, Minitab and any statistical program that we use although this is the test we're testing, we need to incorporate some sort of number into this. So we know if proportion 1 is equal to proportion 2, that's the same thing as saying P1 minus P2 is equal to 0. And a couple ways we can get that, we can just subtract P2 to the other side. So the null hypothesis is that there is zero difference between the first proportion and second proportion. The alternative, what we're testing, is we are testing to see if the proportion has increased. So what we want to know is P1, is it less than P2? Right? Is this second proportion after the survey, is this larger than P1, the proportion before the before the program? So the program sample here is the program, did it have an effect? We want to know if the proportion in the second sample is larger, which means if I wanted to get P1 and P2 on the same side, I could subtract P2 to both sides. In this case, when you subtract them, we get a value that is less than 0. Right? In this case, we subtract P2 over to this side. When we find the difference if P1 is first, then P2, and subtract them, is going to be a negative number. So how are we going to put this into Minitab? Well, in Minitab, we will go to Stat, Basic Statistics, and we have 2 proportions. Now you can use samples in 2 columns because we do have that, but we already found the summarized data. In other words, we found the yeses and the total. So the first group is the first proportion. We found 44 said yes out of 71. So there were 44 that said yes out of 71 trials. And for the second proportion, there was 49 out of 68. There were 49 yeses out of 68 trials. So this is the summarized data. The proportion of yeses was 44 out of 71. And for the second group, after the program was initiated, there's 44 out of 68. So just going into options, let's look at our level of significance is 0.05. So we have a 95 confidence level. Test difference, always going to keep that as 0. And the alternative hypothesis is that this is less than 0. So this is less than. And we are going to use the pooled estimate. Now when you hit OK, these are the results you get. We already saw up here the sample proportions. They should match our p-hats that we found, and they do, 0.620. This one's a little different, or 0.720. Or I guess if we round that to 3 decimal, it would be 0.721. The difference here, we have an upper bound for the confidence interval. We have a test difference. We are looking at whether or not the difference is equal to 0 versus less than 0. Here's our test statistic, and here's our p-value. Our p-value, and I'm going to copy this, and I'm going to paste it. So the p-value is, and I guess I can make this a little larger. The p-value is 0.103. And our alpha level, our level of significance, is 0.05. So what does that mean? Well, since the p-value is larger than the alpha value, we fail to reject the null. So there's no evidence to reject the null hypothesis. So I'm going to just highlight this, right, change the color here. That means that we can't reject the null hypothesis. There's no evidence to reject the null hypothesis. So there is evidence to suggest there is no difference. There's evidence to suggest there is no difference in the proportion of mothers who plan to breastfeed. There's evidence to suggest there's no difference in the proportion of mothers who plan to breastfeed. So did the training sessions help? Well, according to these samples, it didn't look like the training samples had any effect, or there's no evidence to suggest they did.